We're still looking at inequalities involving absolute value. In this session, we'll look at the greater than problem. In the previous sessions, we saw how to solve equations involving absolute value and also the less than problem. We want to recall if the absolute value of x is equal to 4, this is asking us, in words, what number or numbers have a distance of 4 units away from the origin. If we look at the number line, and if this is the origin here, and 4 units to the right and 4 units to the left, then we have divided the number line up into 3 regions. Region number 1 to the left of -4, region number 2 in between -4 and 4, and region number 3 to the right of 4. Well, we see that region number 1 represents further away from the origin. Region number 2 was less than 4 units away, and region number 3 also represents further away than 4 units from the origin. If we're interested in the problem absolute value of x greater than 4, then that means we have to be further away from the origin than 4. Represents region number 1, or it represents region number 3. Region number 1 is to the left of -4, that is, x is less than -4. Or region number 3 is further away or to the right of 4 units. We would say x is greater than 4. To solve problems like the absolute value of x is greater than 4, we look at the number line and we're trying to find the extreme ends of the number line. Mark out the origin, and then 4 units to the right and further away is off to the right hand side of 4. And marking out 4 units to the left, we're situated at -4, and further away to the left would be less than -4. Region number 1 is x is less than -4, or region number 3 is x is greater than +4, and those are the 2 regions we want to try to find when we have a problem involving greater than an absolute value. It gives us a strategy. We want to set up a compound inequality to represent those 2 regions, extreme ends of the number line, the union of 2 sets that point in opposite directions. We have a disjunction, in other words. The strategy would say, if you have the absolute value of some expression is greater than a number, and again, that number is greater than 0, then that expression z must be less than -a, and that's the extreme end to left of -a, or z must be greater than +a, and that's the extreme end to right of a. And looking at your number line, whatever the origin is, and there's a units to the right, you'll be on the right hand side of a, and a units to the left at -a, you'll be less than -a, so the arrows are pointing in opposite directions. Let's look at an example. The absolute value of x minus 7 is greater than 4. We set up our compound inequality. Whatever x is, after you subtract 7 from it, it has to be less than -4. That's region number 1, to the left of -4. Or x minus 7 has to be greater than +4, and again that's region number 3, to the right of +4. Now you want to solve each of those. And to solve the first, you add 7 to both sides, and you end up with x is less than 3. And solving the second inequality, adding 7 again to both sides, you end up with x is greater than 11. And the solution is a union of those 2 sets. And if we look at the number line, those 2 sets should be pointing in opposite directions because we're looking at something further away from the origin. Here's the number 3 on the number line, and x is less than 3, so we'll be shading to the left of 3. And 11 is out here to the right, and greater than 11 is further away from 11, so off to the right hand side of 11. And we would look at the inequality as an interval, starting at -infinity, going to 3, and then union 11 to +infinity. Typically, you'll see the expression as a union of 2 disjointed sets. And if we can look at the geometry again, we want to find the origin. So we ask ourselves, what makes x minus 7 equal to 0? And that tells us that x equals 7 does. If we start at 7, there's the origin, and if we count out 4 units to the right, 8 would be 1 unit to the right, 9 would be 2 units to the right, 10 would be 3 units to the right, and 11 is 4 units to the right. Further away would have to be pointing off to the right-hand side of 11. So that tells us x is greater than 11. And likewise, counting out to the left, 1 unit to the left is at 6, 2 units to the left is at 5, 3 units to the left is at 4, and 4 units to the left is at 3. Further away on the left-hand side of 3 would mean that the arrow has to go into the left-hand side of 3. So that means x would have to be less than 3 units. And so we have the union of the two sets. X is greater than 11 or x is less than 3. That corresponds to what we found before. Let's take a look at another example. The absolute value of 3x minus 2 minus 4 is greater than 5. Well, again, as always in solving inequalities or solving equations, we want to do some simplification. So the first step in this problem would be to isolate the absolute value. We want to put it in the form that we need. That 4 we need to add to both sides. And we end up with the absolute value of 3x minus 2 is greater than 9. And now that's the form that we need. So we apply our strategy and say that these have to be two solutions to this problem. Whatever x is, after you multiply by 3 and subtract 2, you're either further away on the left of negative 9 or further away over the right of positive 9. That means 3x minus 2 has to be less than negative 9, or 3x minus 2 has to be greater than positive 9. And now when you solve, you add 2 to both sides, we end up with 3x is less than negative 7, and then on the other one, adding 2 to both sides, we end up with 3x is greater than 11, and now each of those we want to divide both sides by 3. For the first set, off to the left, we end up with x is less than negative 7 thirds, and then dividing the second inequality by 3, we'd see x is greater than 11 thirds. The union of the two sets as an interval we would have from negative infinity to negative 7 thirds, union 11 thirds to infinity.